Today we're going to learn how to determine the molecular formula of a compound. So we did this before last unit. This time though we're going to be starting off with determining the empirical formula. Then once we know that, we can determine the molecular formula. So something to point out is in letter A, the empirical formula for an ionic compound is a correct formula. So remember, an empirical formula shows the smallest ratio of atoms in a compound. In the formula of an ionic compound, that formula shows already the smallest ratio of ions in the compound. So the formula of an ionic compound is an empirical formula. So let's take a look at some examples where we determine the molecular formula for a compound. Acetylene is a compound known to contain 92.3% carbon and 7.7% hydrogen. This is, of course, by mass. Here's where we take it a step further. Its molecular weight is 26 AMU. What's the molecular formula for acetylene? So here's what we got to do. We got to find the empirical formula first. And then once we know the empirical formula, we can use that to find the molecular formula. So I'm going to let you find the empirical formula, and then I'll show you how to proceed from there. So go ahead, pause the video, stop at the empirical formula. All right, so we should get an empirical formula of CH, a 1-to-1 ratio of carbon to hydrogen. All right, our next step is we need to determine the mass of the empirical formula. And if you recall from last unit, I referred to that as the empirical formula mass. So take the mass of one carbon plus the mass of one hydrogen, and we get about 13 AMU. Next step, just like we learned last unit, is we're going to take the molecular mass, which is given to us in the problem, and we're going to divide it by the empirical formula mass, and that is going to give us a ratio. Rather, maybe a better word is a multiple, not a ratio per se, a multiple. So we see that the molecular mass is twice that as the empirical formula mass, which tells us that the molecular formula is twice the empirical formula. So there's the work. Again, find our whole number multiple, apply that to the empirical formula. So we're going to multiply each subscript in the empirical formula, in this case by 2, and we get C2H2. All right, go ahead and give number 2 a try. A little different problem, but again, mostly the same. Pause the video and work this out. So once again, we get an empirical formula of CH. So both acetylene and benzene have the same empirical formula. Two very different compounds, so they must have different chemical formulas or molecular formulas, which they do. This time our multiple is 6, so we take 6 times the empirical formula, and we get C6H6 for the molecular formula for benzene. All right, go ahead and give this one a try. This time we have a compound that's made of 3 different elements. So we need 2 ratios to determine the empirical formula. We're given the molar mass, which is numerically equivalent to molecular mass, so same process. We want to, again, determine the molecular formula. Go ahead and pause the video and do that now, please. All right, so here's the work. We set up 2 ratios. Notice in each ratio we have oxygen on the bottom. Could have divided by carbon in both cases, so as long as you're dividing by the same thing, it's fine. Usually we divide by the smallest, but we had 2 that are the smallest, so just pick one to divide the other 2 by. And so we get our empirical formula, CH2O. Add up the masses of 1 carbon, 2 hydrogens, and 1 oxygen. We get 30 grams per mole. Notice I put the units the same as what we were given in the problem, so we're given molar mass. So I calculated the molar mass of the empirical formula. Take those numbers, divide them, we get 6 times as massive. So the molecular formula is 6 times that of the empirical formula. And so we end up with C6H12O6 for the molecular formula. All right, that wraps up this lesson. Next time we will continue with hydrates. Thanks for watching.